mathematics, not mathematics. You happen to project I was file in my laptop. If you can project, that will be nice, but it doesn't matter. Otherwise, I'm talking about
provision, but there's provision.
Okay, never mind. Then I'll
You can write something.
No, there's a code here. I can write on the text. No, I had some pictures and so on, but I cannot show that. It's okay. Alright.
No, if you want, I can arrange it.
No, take time. No, there's no point.
மே மாதத்தை போல காட்சியளித்துக் கொண்டிருக்கிற ஜூலை மாதத்தினுடைய ஒரு மாலை நேரத்தில் பை கணித மன்றத்தினுடைய சார்பில் நடைபெற இருக்கின்ற இந்த அழகான அற்புதமான கூட்டத்திற்கு சிறப்பு விருந்தினராக வருகை புரிந்திருக்கின்ற மதிப்பிற்கும் மரியாதைக்கும் அன்பிற்கும் உரிய ஐயா பேராசிரியர் திரு M S ரகுநாதன் அவர்களே, மிகச்சிறந்த ஒரு வரவேற்புரையை அறிமுக உரையை ஆற்றுவதற்காக இந்த நிகழ்வுக்கு வருகை புரிந்திருக்கின்ற மதிப்பிற்குரிய பேராசிரியர் திரு சீனிவாசன் ஐயா அவர்களே, பை கணித மன்றத்தினுடைய நிறுவனர் பேராசிரியர் திரு சிவராமன் அவர்களே, அழைத்தவர் குரலுக்கு உடனே வருவேன் என்றான் கண்ணன் கீதையிலே என்று சொல்லுவார்கள். கீதையிலே கண்ணன் மட்டும் சொல்லுவார்களா? நாங்களும் கூட அழைத்தால் உடனே ஓடி வந்து விடுவோம் என்று சொல்லுகிற வகையிலே ஆர்வத்தோடு திரண்டு இங்கே அமர்ந்திருக்கின்ற இளைஞர்களே, இளைஞர்களே, பை கணித மன்றத்தினுடைய உறுப்பினர்களே, அனைவரையும் இந்த இனிய நிகழ்வுக்கு வருக வருக என்று வரவேற்பதை பெரும் மகிழ்ச்சி அடைகின்றோம். இந்த நிகழ்வுக்கு ஒரு சிறப்பு இருக்கிறது. அந்த பை கணித மன்றத்தினுடைய சார்பில் நடைபெற இருக்கின்ற இந்த நிகழ்ச்சி, பை கணித மன்றம் என்பதனாலே கணிதத்தினுடைய அடிப்படையை சொல்ல வேண்டும் என்று சொன்னால் 875 என்று சொல்லலாம் என்று கருதுகிறேன். அதென்ன 875 அப்படின்னா 875 இதுதான் பை கணித மன்றத்தினுடைய ஒரு சிறப்பு என்றே சொல்லலாம். ஏனென்றால் பை கணித மன்றத்தினுடைய சிறப்பை சொல்லுகிற பொழுது இந்த 3 எண்களுக்குள்ளே சுருக்கமாக அடக்கிவிடலாம் என்று கருதுகிறேன். 8 என்றால் என்ன? 7 ஆண்டுகளுக்கு முன்னாலே பை கணித மன்றம் தொடங்கப்பட்டது, உங்களுக்கு தெரிந்திருக்கும். இது 8வது ஆண்டு. அதில் என்ன சிறப்பு இருக்கு அப்படின்னா, 8வது ஆண்டிலே நடைபெறுகிற முதல் கூட்டமே இந்த சிறப்புக்குரிய கூட்டம். பேராசிரியர் திரு ரகுநாதன் அவர்கள் தலைமையிலே நடைபெற இருக்கிற இந்த கூட்டம் தான் முதல் கூட்டம் என்பது ஒரு சிறப்பு. அது 8. 7 என்ன என்று சொன்னால், இதுவரை பை கணித மன்றத்தின் சார்பிலே வெளிவந்திருக்கிற நூல்கள் மொத்தம் 7. அதான் 7. சரி, அந்த 7க்கு அப்புறமா இருக்கிற 5 என்ன அப்படின்னா, அந்த 7 நூல்கள்ல 5 நூல்களுக்கு தமிழ்நாடு அரசு உட்பட பல்வேறு நிறுவனங்கள் வழங்கக்கூடிய சிறப்பு பரிசுகள் கிடைத்திருக்கின்றன என்பது 5. ஆக 8, 7, 5 இஸ் ஈக்குவல் டு பை கணித மன்றம் என்று சொன்னால் அது பொருத்தமாக இருக்கும் என்று கருதுகிறேன். அப்படிப்பட்ட பை கணித மன்றத்தின் சார்பில் நடைபெற இருக்கின்ற இந்த சிறப்புக்குரிய நிகழ்வுக்கு சிறப்புக்குரிய கணிதத்துறையிலே வல்லுநர் பேராசிரியர் திரு M S சிவராமன் அவர்கள், M S ரகுநாதன் அவர்கள் வருகை புரிந்திருக்கிறார்கள். அவரை பற்றி சொல்வதற்காக ஐயா சீனிவாசன் அவர்கள் வந்திருக்கிறார்கள். என்றாலும் கூட மிகச் சுருக்கமாக அவரை பற்றி தொட்டு காட்ட வேண்டும் என்று சொன்னால், ஐயா அவர்கள் மும்பையிலே IIT அந்த நிறுவனத்தினுடைய கணிதத்துறையினுடைய தலைவராக பணியாற்றி கொண்டிருக்கிறார். அது மட்டுமல்ல, கைதட்ட வேண்டும் என்றால் தாராளமாக கைதட்டலாம். 2001ஆம் ஆண்டிலே இந்திய அரசாங்கம் வழங்கக்கூடிய பத்மஸ்ரீ விருதை பெற்றவர் ஐயா அவர்கள். அது மட்டுமல்ல, 2012ஆம் ஆண்டில் மத்திய அரசாங்கம் வழங்கக்கூடிய மிகச்சிறப்பான விருதான பத்ம விபூஷன் விருதையும் பெற்றவர் ஐயா. பத்மபூஷன் விருதை பெற்றவர். அது மட்டுமல்ல, 2010ஆம் ஆண்டில் ஹைதராபாத் நகரிலே உலக கணித மாநாடு ஒன்று நடைபெற்றது. அந்த மாநாட்டினுடைய தலைவராக இருந்து செயல்பட்டவர் ஐயா. இன்னும் பல்வேறு அறிவியல் அமைப்புகளோடு தொடர்பு கொண்டு மிகச்சிறந்த ஒரு கணித அறிஞராக திகழ்ந்து கொண்டிருப்பவர். அது மட்டுமல்ல, மிக குறைவான நபர்களே FRS என்கிற இந்த கௌரவத்தை, இந்த ஃபெலோஷிப்பை அடைந்திருக்கிறார்கள். அதிலே குறிப்பிடத்தக்கவராக விளங்கி கொண்டிருப்பவர் ஐயா அவர்கள் என்று சொன்னால் அது மிக லண்டனில் இருந்து தரப்படுகிற அந்த ஃபெலோஷிப் FRS, அந்த ஃபெலோஷிப்பை பெற்றவர் ஐயா அவர்கள். ஆக இப்படி இன்னும் பல்வேறு சிறப்புகளை பெற்று கணித துறையிலே மிகச்சிறந்த வல்லுநராக திகழ்ந்து கொண்டிருக்கிற மதிப்பிற்கு மரியாதைக்கும் MS ரகுநாதன் ஐயா அவர்கள் இன்றைக்கு பை கணித மன்றத்தினுடைய இந்த கூட்டத்திலே கலந்து கொண்டு சிறப்பித்திருப்பது பை கணித மன்றத்திற்கும் பை கணித மன்ற உறுப்பினர்களுக்கும் மிக பெரும் ஒரு கௌரவம் என்றே சொல்லலாம். அப்படிப்பட்ட ஐயா அவர்களை பற்றிய இன்னும் விரிவான ஒரு காட்சியை பேராசிரியர் மதிப்பிற்கும் அன்பிற்கும் உரிய திரு சீனிவாசன் அவர்கள் இப்பொழுது நிகழ்த்துவார்கள். அவரை உங்கள் அனைவரின் சார்பாக இப்போது வருக வருக என்று அழைக்கிறோம்.
Friends, there are some people, whose presence itself is a source of inspiration, and Professor Raghunathan is one of those, rare living legends that we have with us. To the mathematical crowd, we don't need his introduction, but for this crowd, I think I will read out certain things as an information. Professor Raghunathan, at the moment, he is the head of something called National Center for Mathematics, which is located in Indian Institute of Technology, Mumbai. Before that, he was Professor Emeritus at TIFR. He was a professor in TIFR for a long, long time. He did his PhD under Professor M S Raghunathan. As my good friend informed before about the awards and all, there are number of awards. The most prominent of them is Shanti Swarup Bhatnagar Award in 1977, Third World Academy Prizes, Fellow of Royal Society, Srinivasa Ramanujan Medal, SN Bose Professorship, and Padma Shri and Padma Bhushan as mentioned earlier. Okay. You will be happy to know that Professor Raghunathan, his early education was done in Chennai. So he studied in PS High School, Mylapore. After that, he joined Madras Christian College High School, where he did his SSLC. And there is a very interesting story which is there in Wikipedia. Apparently, when he was in a Sanskrit exam, after writing the exam, unmindfully, he went with the answer sheet itself. And someone caught him at the gate, and the principal was kind enough to let him, submit the answer sheets again. So I don't know how far it is true. Can illustrate us later. Okay. So, one of the main areas of research, his research is discrete subgroups of Lie groups. It's a very interesting field in mathematics, which has been his main, theme of his work. He made several important contributions in that area. Particular importance is, in shaping the Indian mathematics. He has been very, very active for last 5 decades or more than that in shaping the mathematical, fate of India. So he has been played an extremely important role in promotion of mathematics through various scientific bodies in both advisory and administrative capacity. The most notable one is the formation of National Board for Higher Mathematics. All of you know NBHM. Okay, it was started in 1983, and I think Professor Raghunathan conceived the idea of NBHM. Okay, and he has been the chairman of that for a number of years. chairman of NBHM. As you know, the board has undertaken a variety of activities through the years. Apart from providing financial support to mathematics library around the country, so most universities, they get grants from NBHM, National Board for Higher Mathematics. Okay? Grants for research projects, organizing conferences, travel to both national and international events, and so on. The board has taken a proactive role in tapping mathematical talent through various activities such as Olympiad activity, mathematics training and talent search, MTTS program, scholarships, fellowships at MSc, PhD and postdoctoral levels. I was also a recipient of NBHM PhD scholarship, thanks to Professor Raghunathan's plan. And Nurture program. This is one of the very good programs that are happening. It's a follow-up of this Olympiad. Students are being trained after that. That's called Nurture program, conceived completely by Professor Raghunathan to support learning of mathematics by students, even while pursuing other career options. Okay. Not only that, Professor Raghunathan has organized many important conferences in our country. Okay. The most notable ones are Ramanujan centenary celebrations in 1987, the 100 years of Ramanujan's birth anniversary, which was attended by international crowd. Indoor AMS conference in 2003. As you know, International Congress of Mathematics that was held in India under Professor Raghunathan's leadership. And most recently, the Legacy of Ramanujan conference in 2012. Okay, these are the few things that I mentioned, and there is enough number of things. I mean, one will take hours and hours, but I don't want to be in between you and Professor Raghunathan. So I would like to invite him, and we are very happy, sir, here. And also I would like to thank Sivaram, who first I would like to thank Professor Raghunathan because just 2 days back, when I happened to meet him, I mentioned him about this association, and he has readily agreed to come and to discuss with you people. And also I thank Sivaram for arranging all these things. So I think that will stop it.
மதிப்பிற்குரிய இன்றைய சிறப்பு விருந்தினரான பேராசிரியர் M S ரகுநாதன் அவர்களை பற்றிய அழகான அறிமுக உரையை அவருடைய சிறப்புகளை சிறப்பான முறையில் தொகுத்து கூறியிருக்கிறார் திரு சீனிவாசன் அவர்கள். அவருக்கு நம்முடைய நன்றியை இந்த நேரத்தில் தெரிவித்துக் கொள்கிறோம். அடுத்த சிறப்புரைக்கு செல்வதற்கு முன்னால் பை கணித மன்றத்தினுடைய நோக்கத்தை பற்றி உங்களுக்கு தெரியும் என்றாலும் கூட ஒரு வரியில் அதை பற்றி சொல்ல விரும்புகிறேன். பை கணித மன்றம் என்பது கணிதத்தை அதனுடைய சிறப்புகளை மாணவரிடத்தில் கொண்டு செல்ல வேண்டும் என்கிற நோக்கத்தை முக்கியமாக கொண்டு இயங்கிக் கொண்டிருக்கிற ஒரு மன்றம் என்பது எல்லோருக்கும் தெரியும். அது மட்டுமல்ல, மாணவர்களுடைய கணித திறமையை மட்டுமல்ல, கணித மேதை ராமானுஜன் அவர்களுடைய சிறப்புகளையும் உலகமெங்கும் பரப்ப வேண்டும் என்கிற ஒரு கொள்கையும் வைத்திருக்கிற ஒரு அமைப்பு. இதனுடைய செயல்பாடுகளை பார்த்த காரணத்தினால்தான் நன்கொடைகள் மூலமாக இந்த அமைப்பிற்கு மிகப்பெரிய ஆக்கமும் ஊக்கமும் சேர்த்து கொண்டிருக்கிறது என்று சொல்லலாம். ஒரு சான்றாக ஒன்றை சொல்ல வேண்டும் என்றால், அமெரிக்காவில் இருக்கிற கணித பேராசிரியர் ரோமன் கொலன்ஸ்கி என்பவர் நம்முடைய இந்திய ரூபாயின் மதிப்பில் 50,000 ரூபாயை நன்கொடையாக பை கணிதம் அறிஞர்களும் சரி மற்றவர்களும் சரி தமிழ்நாட்டில் இருக்கக்கூடிய அமைப்பை அங்கீகரிக்கிறார்கள், ஆதரிக்கிறார்கள், ஊக்குவிக்கிறார்கள் என்பதை உங்களுடைய சிந்தனைக்கு கொண்டு வருகிறது. அப்படிப்பட்ட சிறப்புக்குரிய பை கணித மன்றத்தினுடைய நிறுவனர் திரு சிவராமன் அவர்கள் நாளும் பொழுதும் பல்வேறு வகையில் ஈடுபட்டு சிறப்புக்குரிய முறையில் கணிதத்தினுடைய சிறப்புகளை மாணவர்களிடத்தில் கொண்டு செல்வதற்காக அரும்பாடுபட்டு கொண்டிருக்கிறார். சுருக்கமாக சொல்ல வேண்டும் என்றால், இங்கே சீனிவாசன் ஐயாவை அறிமுகப்படுத்துவது சொன்னார்கள். அவர் தமிழகத்தைச் சேர்ந்தவர், மயிலாப்பூரிலே படித்தவர், சென்னை கிறித்துவ கல்லூரியிலே படித்தவர் என்று சொன்னார். எனக்கு உடனே தோன்றுகிறது, எந்த அறிஞராக இருந்தாலும் எந்த துறையை சார்ந்தவராக இருந்தாலும் தமிழகத்திலே இருந்துதான் எல்லோருமே உலகத்திற்கு புகழை ஈட்டிக் கொண்டு தந்திருக்கிறார்கள் என்கிற ஒரு கருத்திற்கு திரு ரகுநாதன் ஐயா அவர்களும் மிகச்சிறந்த சான்றாக விளங்கி கொண்டிருக்கிறார்கள் என்பதை நினைக்கிற பொழுது மிகவும் மகிழ்ச்சியாக இருக்கிறது. சுருக்கமாக சொல்ல வேண்டுமென்றால், இந்த ஆண்டு அக்டோபர் மாதம் 22ஆம் தேதி தீபாவளி வருகிறது. சம்பந்தமே இல்லாமல் பேசுகிறேன் நினைக்கக்கூடாது. அக்டோபர் 22ஆம் தேதி தீபாவளி வருகிறது என்றால் அது எல்லோருக்கும், ஆனால் பை கணித மன்றத்திற்கும் கணித ஆர்வலர்களுக்கும் தீபாவளி அடுத்த வெள்ளிக்கிழமை வருகிறது. என்ன என்று பார்க்கிறீர்களா? அடுத்த வெள்ளிக்கிழமை தான் கணித மேதை ராமானுஜன் அவர்களை பற்றிய திரைப்படம் வெளியாகிறது. அந்த நாள் தான் கணித மன்றத்திற்கும் கணித ஆர்வலர்களுக்கும் அறிஞர்களுக்கும் தீபாவளி என்று சொல்லி, அப்படிப்பட்ட ராமானுஜனுடைய புகழை பரப்பிக் கொண்டிருக்கிற பை கணித மன்றத்தினுடைய இந்த சிறப்புக்குரிய நிகழ்ச்சிக்கு வருகை தந்து சிறப்பித்துக் கொண்டிருக்கிற மதிப்பிற்கும் மரியாதைக்கும் அன்பிற்கும் உரிய பேராசிரியர் ஐயா திரு M S ரகுநாதன் அவர்களை சிறப்புரை ஆற்றுமாறு இந்த இணைய நேரத்திலே உங்கள் அனைவரின் சார்பாக அன்போடு கேட்டுக்கொள்கிறேன்.
இன்னும் 3 நாட்களுக்கு முன்னே தெரிஞ்சிருந்தா தமிழில் பேசி இப்போ என்னால் பேச முடியாது, தயாராக வரல, அதனால் இங்கிலீஷ் தான் பேச போகிறேன். ஸோ அதுக்கு என்ன மன்னிக்க வேண்டும். எதை பற்றி பேசுறது? திஸ் ஒன்ட் பி ராம்பிளிங் டாக். ஏதோ சம்மந்தம் இல்லாத விஷயங்கள்லாம் ஒரு விஷயத்தை ஏதோ பண்ண போகிறேன். ஏன்னா நான் really prepare பண்ணிட்டேன். So I want to talk in a random fashion. Firstly, everybody knows Ramanujan. But after Ramanujan, there have been outstanding mathematicians whose names are not known. The greatest Indian mathematician after Ramanujan. Does anybody here know who the greatest mathematician after Ramanujan? Who can be considered the greatest mathematician after Ramanujan? S.S. Pillai from Tamil Nadu, but the really greatest man was Harishchandra, a man mathematician named Harishchandra. But I must say, Harishchandra most of the time worked abroad. He worked in the United States, America, not in India. But he was easily the greatest mathematician after Ramanujan. One can even ask, who is greater, Ramanujan or Harishchandra? It's a moot question.
Is he such a big person, Harishchandra?
Yes. He's one of the greatest of the 20th century mathematics in the world, without question. After Ramanujan, from India, he is the undoubtedly the greatest mathematician. He worked in an area close to mine. The area is known as Lie groups. Lie groups are some objects which were invented by a Norwegian mathematician by name Sophus Lie, spelled L-I-E, but pronounced Lie, not Lie. Sophus, that's the kind of area I work in, but Harishchandra made tremendous contributions to that area. And in fact, when he started, it was not a very important area. It was, in fact, more physics people were interested in that area because it had applications to physics. Mathematicians were not paying much attention to it. But after Harishchandra's work, it became a very central and important topic in mathematics. In the course of some 2 decades, he worked intensely in this field and brought it from the peripherals of mathematics to the heart of mathematics. Today, the area of Lie groups has importance in practically every other branch of mathematics, every other mathematical field, including number theory, which is Ramanujan's favorite. So, Harishchandra was the greatest mathematician. And then, from Tamil Nadu, there have been very good mathematicians. They may not be as great as Ramanujan and Harishchandra, but very outstanding mathematicians. There was a man by the name of Anandarao, who was a professor at Presidency College in Chennai. I keep saying Madras. Anyway, so he was actually, this man was in Cambridge at the same time as Ramanujan. He went to Cambridge as a student. He came from a well-to-do family, and they could even afford to send him to Cambridge to study there. But unlike Ramanujan, who was very poor and went without a degree, this man finished his degree at Madras University and then went to Cambridge to study. He was also a student of Hardy, the same Hardy who helped Ramanujan. And he did some very beautiful work when he was in Cambridge. In fact, he won a coveted prize, an Adams Prize, available for students, PhD students in Cambridge. And then when he came back to India, immediately he was made professor at President's College. He had a degree from Cambridge. He knew Ramanujan at Cambridge. They met, talked to each other. And in his report, in one of his letters, he says Ramanujan was a self-effacing person. He was never projected himself. Though he was a genius, he never acted like that. But other people were always polite and nice and so on. He was one of the, in fact, he was born in he was some 6 years junior to Ramanujan. And he is not, you cannot say he was one of the people inspired by Ramanujan, because the Ramanujan story, he decided to do mathematics long before the Ramanujan story came to be known. He was only 6 years junior to Ramanujan. And then there was another mathematician about the same age, named Vajirana Swami. He also went to England to study, but not to Cambridge. You remember where he went to some other university, studied there, and he also came back and joined Madras University. First time a professor was a department of mathematics was started in Madras University. Yeah, he was head of the department. He was reader. He was appointed reader in that department. That's the first time the department was started. And he was actually when he started, he was the only person in the department. There's no other person. Actually, the department was supposed to be started much earlier when Ramanujan came back from England. But since he fell ill and died, it never materialized. So it took another 10 years before that thing actually materialized. And then Vajirana Swami was appointed. These two people played a very big role in developing mathematics in Madras, in Chennai. And they had a number of very good students. Some of them became really good mathematicians, outstanding mathematicians. One of them was Pillai. S.S. Pillai was a number theory, mathematician working in number theory. He contributed to what is known as the Baring's problem. Maybe I'll tell you a thing or two about Baring problem. You people know the name Lagrange, famous French mathematician. Lagrange is the name. He worked in different areas, among them number theory. And one of the things he proved is the following: take any number n, any number n can be expressed as the sum of 4 squares. That is, n can be written as a1 square plus a2 square plus a3 square plus a4 square. a1, a2, a4 integers. Any integer can be written as sum of 4 squares. Any positive integer, of course. This is a theorem which Raghunath proved 200 years ago, something like that. And of course, mathematicians being what they are, they ask questions. One question is answered, they have another question to ask which is close to it. What about cubes? Can every number be written as a sum of cubes? Maybe not 4, maybe 5, maybe 3, I don't know. What number can you do that? Of course, you are not satisfied with that even if you solve it. What about 4th powers, 5th powers? In general, is it question that was asked is the following by a man named Baring. Suppose R is any integer greater than 0. Does there exist some number, a number gr, depending on R, of course, that's why I write gr here, depending on R, such that every integer, every positive integer is a sum of gr r powers. For example, when r is 2, Lagrange says g2 is 4. can be written as sum of 4 second powers. So question, that is, you want to write any n as a1 power r as a2 power r, some a gr power. Is there a gr like this? Every number should be written like this. So Lagrange theorem, Lagrange result can be said as G2 is 4. Everything can be written as sum of 4 squares, 4 second powers. This is a general question which bearing asked. When you write any number as a sum of gr rth powers, gr will depend on r, of course. For G2, for 2 we know it's 4, G2 is 4, G3 will be some number if it exists. Maybe you cannot do that. Maybe you can. This is a question first based. And there's also strong tendency, it may start with something very special like squares, but then you ask a very general question. And mathematicians would like to answer the general question. And this question is answered in the affirmative by one of the greatest figures of mathematics of all time, a man by name Hilbert. Hilbert, if you ask mathematical community who are the all-time great mathematicians, and you name some, I mean, in all the history of mathematics, 3 names stand out: Archimedes, Newton, and Hilbert. These are the names who are the greatest at all times. And Hilbert is the most recent. He lived into the 20th century. He started his career in the 19th century, but lived into the 20th century. He was a very interesting character. Maybe I'll say something about him at some point. Anyway, so he said, yes, there is given r, there is a number gr. But he didn't exactly determine what. Can you determine gr in terms of r? Is the question. It's a function of r. So what kind of function can you write down something? Is the question. And many people worked on this problem. And is it? I don't remember who proved this. But gr was determined completely. I think it is Ramanujan, Russian mathematician, determined for all r greater than or equal to 7. Hilbert proved that there is some gr for every r, but the exact gr was determined for r greater than 7 by different people. I think, I'm not sure. Ramanujan made a big contribution to that. Ramanujan was a Russian mathematician who made a contribution. For r greater than 7 was settled well before the 1920s. One of the outstanding problems was G6. Very difficult to determine. People were trying to do that, and Pillai determined G6. That is the great contribution that Pillai made, and Pillai became well known after that. G6 was determined by Pillai. Then some others worked on G5, etc. G4 was a tough nut to crack. That took a long time. It was only about 20 years ago. Again, an Indian mathematician was involved. The G4 was determined. And this Indian mathematician is Professor R. Balasubramanian, whose name you're probably familiar with, the director of Institute of Mathematical Sciences. He, along with 2 other French people, by name Deslier and Dresch, settled the final question about G4. G4 was open for a long time. G3, G5 were done earlier. G6 was done by achievement of Pillai, and then the next big achievement was G4, and that's about 20 years ago, done by Balasubramanian. So this is a variance problem. Indians have had an important role in the final resolution of the problem. Pillai, in fact, his life is something of a tragic story. His mother died when he was already an infant, not even a year old, and his father brought him up with great difficulty with the help of some aged woman relative. But when he was to sit for the SSC exam, his father died. But he still did well in the exam, and then a teacher in a local college helped him with some money to pursue the college studies, and he studied in Maharaja's College in Trivandrum. His father was lived in Trivandrum, and then he passed out with distinction from the BA honors or whatever in Maharaja College, and then he came to Madras and worked with Anand Rao for a degree. And Anand Rao was interested in number theory also, but he was mainly working in analysis. But Pillai branched off on his own, but he had great regard for Anand Rao. He is spoken glowingly about Anand Rao in places, and he says he owes him a lot, Anand Rao. And in 1950, he was invited to the Institute for Advanced Study in Princeton. This is a famous institute. This is the institute where Albert Einstein worked. The Institute for Advanced Study, what they do is that they have some permanent members. Einstein is a permanent member, for instance. Harishchandra became a permanent member of the Institute for Advanced Study much later, of course. That is in the 1960s that he became. Anyway, in 1950, Pillai was invited to the Institute for Advanced Study to spend a year. Remember, every year they invite some people for a year. And he was also to participate in the International Congress of Mathematicians, which was taking place at Harvard University in Boston. Unfortunately, the plane by which he went crashed in Cairo. He lost his life. That he was 51 or something. So it's a tragic life altogether. He was one of the greats who come from this part of the country. And then there was another man by name Vijay Raghavan. Vijay Raghavan was again a student of Anand Rao, and his career had some similarities with Ramanujan's. He didn't come from a very poor family, but he failed this BA honours examination. Partly because, once again, like Ramanujan, he got interested in more serious mathematics and did not pay attention to the studies in the class, and so he didn't do well. But despite that, he managed to go to Oxford to work with Hardy. Hardy had moved from Cambridge to Oxford, so he went to Oxford to work with Hardy. And that was possible partly because Anand Rao, even though he had failed in the exams and so on, knew him to be a bright student and gave appropriate recommendations so that Hardy would accept him as a student. So he went to Cambridge, worked there, and wrote a very nice thesis, came back, and then he was, when he came back, I don't know where he was first employed, but he got a job at Aligarh University, Aligarh Muslim University, which is located in Aligarh in the north. That's where his early career was there. There's an interesting, that's a very interesting development. And now talk about a mathematician who was in India, was for 2 years, but was not Indian. This was a man by name Andre Bain, a French mathematician. Andre Bain is a French mathematician and one of the greats of the 20th century, undoubtedly. In fact, he lived into the 21st century, died between 2003 or 2004, something like that time. At the ripe old age of 93, something like that, 91. Andre Bain was a very interesting personality. See, he was a student in France at the famed École Normale Supérieure, as they call it. Literally means superior high school, not École Normale. That's the name. ENS is the abbreviation they use, and in fact, many outstanding French mathematicians and physicists come from the École Normale. In fact, it's something like for pure science, it's like our IITs for engineering. So it's a prestigious institution, and it's very difficult to get into it. And for engineering, there's also another institution known as École Polytechnique, which is also very prestigious. But this is not exclusively, École Normale is exclusively science. This combines engineering as well as science. And some of the greatest. Sorry?
École Polytechnique.
École Polytechnique.
EPF.
EPF is, no. Maybe. No, there's more than one École Polytechnique. There's one in Paris, and there's elsewhere also there. So I'm not sure what EPFL maybe is the
The
abbreviation.
Einstein did study in E242.
Huh?
Did the Einstein study here?
No. The most famous student of Macquarie Polytechnic is Evariste Galois. Have you people heard of Galois? Group, the one who essentially discovered group theory. Actually, his most important contribution is known as Galois theory, which is something to do very much to do with number theory. Galois, whose name is spelled like this, the French, OIS becomes WA. When I was a student, because I read out this Galois, and I was corrected much later that it should be Galois. Anyway, Galois was the most famous student at Macquarie Polytechnic. His life story is a very interesting story, and maybe I'll say something about that. But anyway, coming back, Andre Bain was a student at the Macquarie Superior and was essentially just about finished his thesis and was looking for a first job. Around that time, a man by name Syed Ross Massoud was in Paris. He had been just appointed. He was actually holidaying in Paris, but he got a telegram from India saying that he had been appointed Vice Chancellor of the Aligarh University. And this man was a Francophile, liked for everything French and so on. And he felt strongly that any good university should have a chair in French culture. So he approached a friend of his, a man by the name of Sylvain Lévy. Sylvain Lévy is actually a famous Indologist. He had done a lot of work on Indian culture at that time, and was a good Sanskrit scholar. So he went to Sylvain Lévy and asked him for help to recruit a good professor for French culture. Sylvain Lévy recommended Andre Bain. Andre Bain was a mathematics student who had just finished his degree, but he had impressed Sylvain Lévy greatly because he was also attending lectures which Sylvain Lévy was giving at the Sorbonne, which is one of the famous institutions in Paris. At the Sorbonne, where Sylvain Lévy was a professor, he was giving a course of lectures. His course of lectures was on the famous Kalidasa poem Meghaduta. Which is easily considered the most lyrical poem, the best possible poem in all of Sanskrit literature, Meghaduta. It's not a single poem, it's a long poem. Anyway, Sylvain Lévy was actually giving the course of lectures on Meghaduta. And Bain was attending those lectures. Bain had learned some Sanskrit and was attending those lectures. And he had impressed Sylvain Lévy apparently, also with his knowledge of French culture and things like that. And Sylvain Lévy recommended his name to Syed Ross Massoud as for a chair in French culture. And things being what they were, they had Ross Massoud had an interview with Bain, and on the spot offered him the job. You don't have to go through any legal processes for appointments in those days, and Vice Chancellor is very powerful, and he simply appointed him as and Bain accepted. And then it turned out, months together he didn't hear from Ross Massoud. And then this is the story he told us himself. I mean, Bain happened to visit the Tata Institute in the 1960s, at which time some of this story was from him. And he told us, at some point, he got a letter from Aligarh University after about a year, more than 6 months, offering him a chair in mathematics. And Bain adds, I do not know when this Vice Chancellor came to know that I am a mathematician and not an expert in French culture. Anyway, he was appointed this job and happily came to. And he was given appointment as head of the department of mathematics, professor and head of the department, with full freedom to appoint or sack faculty members. This was at the age of 26. Bain was 26 at the time. And he came to Aligarh in 1930. Or 31, something like that. And as soon as he came, he did sack one of his colleagues and sent another colleague on leave for 1 year. And then he tells us, I sent him on leave. Very regretfully, I should have sent him also away, but I gave him leave and he came back. Anyway, so he joined there, and then he recruited Vijayaraghavan. Vijayaraghavan was somewhat older than Bain, some 4 or 5 years older than Bain, but was appointed at a junior level. So So, and they got along very well, Andhra and Vijayaraghavan. Vijayaraghavan had done some good work, which is noticed by Andhra. That's why he brought him there. Well, Vijayaraghavan and they continued, they were good. Andhra was of course interested in Indian culture and traveled a great deal. In fact, that was in 1930s. In 32, he left the job. He resigned because he had differences with the Vice Chancellor, who was initially so very friendly, but later they fell out and he had to go. And that was in 1932 that he left India, but he came back some 36 years later, 1968. That's the first time he was coming back after he left. He visited Tata Institute to participate in a conference, algebraic geometry. It was interesting because when he came, he also visited other places. And we at the Tata Institute put him up at the fanciest hotel in town, the Taj, as it's called, Taj Mahal Hotel. And we were very pleased with ourselves for offering him such good hospitality. But what does man do? He goes to Delhi. There is the guest of the president, Zakir Hussain, staying at the president's home with the president. Zakir Hussain was a colleague of his at Aligarh University. That old friendship, 36 years later, he goes and stays with him. Then he goes to Calcutta. Where does he stay? He stays at the Rajbhavan, the governor. The governor of Raj at that time was a man named Dharamveera, who happened to be collector of Aligarh when Vail was there. And that was the friendship he stuck up. And 36 years later, he goes and stays at the Rajbhavan. But the most interesting thing happened to him in Chennai. When he came to Chennai, he wanted to go see Rajaji. Now, he so happened that during the time he was in Aligarh, he made frequent trips to Delhi where he got in touch with the Congress leaders. And on one occasion, he had apparently met Rajaji and so on. So he wanted to meet Rajaji. So he made an appointment, went to see Rajaji, and began. Apparently, it is what he told us. Began by saying, "I don't know if you remember me. I was." And then Rajaji cut him short. He said, "Yes, I remember you very well. You were the professor, French professor who was at Aligarh University. And I find that your English is as bad as ever." This is what Vail told us, that Rajaji said this. And of course, Vail's English is extraordinarily good. But his accent is always, he never got rid of his French accent in speaking English. So what Rajaji meant was that his accent has not gone, but he can write beautifully in English, like Vail. So that's, and Vail is not the kind of person who takes jokes at his expense very sportingly, but apparently he had great regard for Rajaji, so he was willing to tell us this story. Anyway, so, well, this is the kind of gossip I'll go on with. I hope you don't mind, and I do hope you even like it. That's the expectation. Anyway, Vijayaraghavan was very close to Andhra, but as I said, after 2 years, Andhra left. So that's Vijayaraghavan's name, Raghunathan. He worked in number theory and analysis. Vijayaraghavan's an interesting person. He was not interested in general theory and things of kind. Specific problems he wanted to get into and try to solve them. That was his nature. Whereas someone like Andhra was very different. He was interested in building theories. In fact, some of the theories he built are the foundations of many subjects now. Andhra Vijayaraghavan, on the other hand, take up specific problems and try to solve it. He was not interested in general theory. Vail's philosophy was, you build a general theory, so problem solving will automatically follow. If you have a good theory, any problem can be solved within the framework of the theory. That was his philosophy, but Vijayaraghavan is the very opposite. And he would go about, apparently, I am told that he would go about saying that I can agree that you know a certain theorem only if you know at least 3 proofs, one of which is wrong. That would be Vijayaraghavan's comment. But of course, he himself will stand up to scrutiny when he claimed he knew some theorem or other sometimes. Anyway, Vijayaraghavan was, he later on became, there's some, now the Madras University Mathematics department is called the Ramanujan Institute. But there was actually a Ramanujan Institute, which was started by the industrialist Algappa Chettiar, who gave some money for that. And the first director of that institute was Vijayaraghavan. But later on, the institute ran out of money and it was absorbed into Madras University and became Mathematics department. So Vijayaraghavan was the first and only director of now extinct Ramanujan Institute. Anyway, so those are the big names there's another important name from Chennai, but he was not again. He was again a Frenchman. Man, his name is Reverend Father Racine. Father Racine taught at Lara College. He was there for something like 40 years. He came to India. He's a Jesuit priest, and he came to India because the Jesuit order sent him here to teach. They sent people around all over the place. And he first taught I think at Palankote in some college, and then I think he taught at St. Joseph's at Trichy for some time, and then moved to Lara College, where he had tremendous influence on many students. The point about Racine was, in India, before Racine came on the scene, and before Vaidyanatha Swami and Racine came on the scene, most of the people pursued mathematics, which was what was being done in Cambridge. Whatever, essentially were imitating whatever was being done in Cambridge. Cambridge was our leader, so to speak. It is natural because, among other things, Ramanujan went to Cambridge, and of course we were colony of the British, and so Cambridge was the place for science in the British system. So it is natural that it was, and it is not a bad thing at all, because after all, Ramanujan could grow only because of his contacts with Cambridge and so on. But on the other hand, many interesting developments were taking place in Europe, and many people in England were not paying any attention to it. In fact, the most interesting mathematics in the 1920s and 30s was happening not in England, but in Paris and Göttingen in Germany. Those are the places which were really central for mathematical developments. Racine, being a Frenchman, knew many of these developments, and when he came to India, he brought that knowledge with him to be spread here. So, exposure to European mathematics, as distinct from Cambridge mathematics, came to Indian students only through Racine and Vaidyanatha Swami. Vaidyanatha Swami didn't go to Cambridge, he went somewhere else, but fortunately pursued areas which are different from what is being pursued by most Britishers. He was looking at things like topology, and which was at that time not the favorite of Cambridge. And he also brought these new areas into mathematics. And in fact, people like M S Raghunathan and Pillai were exposed to good mathematics. There is one other important mathematician who benefited greatly, especially from Racine. His name is M S Raghunathan. In fact, M S Raghunathan was probably the first Madras mathematician to really branch out into areas in which Cambridge was not interested. He worked on partial differential equations. He did some very profound work which 20 years later was to influence the work of another Indian mathematician, a man named Patodi, who died young unfortunately. He did some very beautiful work, but it all came from M S Raghunathan's work. M S Raghunathan, his thesis was something on parabolic differential equations, but later on he did some work on what are known as elliptic differential equations, which is the one which had a crucial role in later work. So these are some of the Madras figures of great importance. But the greatest of them all after Ramanujan was, as I said, Harishchandra, who also had was a very interesting person as a human being, and he also had a very interesting life, so to speak. His name is Harishchandra was from UP. His father was a railway employee. He was an engineer in the railways, and he was transferred around many places in the north. And so he did not stay in one place, but his maternal grandfather was domiciled in Kanpur. So he spent a lot of time in his maternal grandfather's place and went to school there in Kanpur and so on. And later went to the university in Allahabad. In Allahabad, when he did his master's degree, one of his teachers was K.S. Krishna. He did the masters in physics, not mathematics, and one of his teachers was the famous Indian physicist K.S. Krishna. Krishna was very impressed with Harishchandra, and Krishna recommended that he should go work with Homi Baba in Bangalore. Homi Baba at that time was at the Institute of Science in Bangalore, and Krishna recommended that Harishchandra to Baba and Baba became a student. One interesting story about Harishchandra at this point is that one of his physics final exam papers, he scored 100% marks in the physics exam. The examiner was C.V. Raman. So that is, and when he went to Bangalore, he got to meet Raman, and they became very good friends, Raman and Harishchandra. They used to go for long walks apparently. And he was working with Homi Baba. At some point, Homi Baba thought this bright young man should be exposed to even better physicists than himself, and they sent him to Cambridge to work with another great name in physics, particularly in quantum mechanics, P.A. Dirac, or Adrian Maurice Dirac is the name. British physicist, one of the architects of quantum mechanics, is one of the most important figures in 20th century physics. So Harishchandra went to work with Dirac. He was a physicist at the time. And Dirac, as it turned out, when he went to work with Dirac, after some time Dirac was invited to the Institute for Advanced Study in Princeton to spend the year there. And he decided to take Harishchandra along with him. So he went with Dirac to work at the Institute for Advanced Study. And then he met a mathematician by the name Chevalier. Chevalier was a French mathematician, one of the outstanding mathematicians in the 20th century. And he was spending some time in France. He was actually French, but he was spending some time in Princeton. And Harishchandra came into contact with him. Harishchandra's work in physics involved some Lie groups. And Chevalier was one of the experts in Lie groups, so he started talking to Chevalier. And he simply sold on mathematics. He quit physics and moved to mathematics. And in the next 10 years worked on Lie groups and produced some of the most fantastic work in that area. It's 2 decades. What was considered as a somewhat peripheral area of mathematics, so-called representation Lie groups, after Harishchandra's work became very central to all kinds of physics and mathematics. Because now Lie groups has applications in geometry, in number theory, in physics, of course, in various things. It's become a very important field. So, that is Harishchandra. Well, then 2 other mathematicians, one other mathematician who should probably be mentioned from the north, who is in the same league as these people, Chawla is the name. So he is another Indian mathematician of considerable stature. He is in the same league as the other people I mentioned, not quite the Harishchandra league, but the rest of them. All these people, Chawla, Vijayaraghavan, Pillai, Meenakshi Sundaram, they are all very outstanding people, but they run below people like Harishchandra. Well, Chawla was in fact grew up in Lahore and went to college in Lahore, took a degree there, but during the partition he was one of the refugees who come to India, his family. And then he worked for a while in Delhi at St. Stephen's College, where he married a student of his, he fell in love with a student and married her. And then moved to the United States, because after partition his life was not very comfortable or happy in Delhi, so he moved to the US and never came back. But he had done already some interesting work when he was in India, and he is quite well known in the mathematical community. And all the names I mentioned will be known in parts of the mathematical community where they work in the corresponding area. But someone like Harishchandra is known to the entire mathematical community because his work transcends any particular field. So, these are some of the big names in Indian mathematics. And now, there's one other name I would like to mention. All these people are no more, of course. In fact, many of the mathematicians unfortunately died relatively young, including Harishchandra. Harishchandra died at the age of 60. He died in 1983. That's when he died. As I told you, Vijayaraghavan also died in his 50s. And Chawla lived a long time. He probably lived up to his 90th year or something at that time. Meenakshi Sundaram, well, he also died in his 50s, late 50s. Let's see. Of course, Ramanujan died very young as well. You know, as for mathematicians dying young, there are two cases even more tragic than Ramanujan's. One is Galba. I think I mentioned 21. He died at the age of 21. By the time he had made the great discovery which is now known as Galba. His name is never to be erased from history of mathematics, but that was achieved by the age of 21. The other mathematician, it is Galba wrote down, the other mathematician who died young is famous mathematician who died in Abel. Abel is a Norwegian mathematician. He died at the age of 26, before which he had discovered some very profound mathematical theories. Developed. One of the things he did was, you're all familiar with the quadratic equation, you know how to solve it. Ax squared plus bx plus c equals 0, solution minus b plus r minus root of b squared plus 4ac by 2a, everyone knows that. You learn it at school, as a matter of fact. What about the cubic? Do any of you know how to solve a cubic? Most probably not. Sorry? Synthetic equation? I don't know. So there are formulas like in the case of the quadratic equation. You first make a transformation so that the equation is in a more manageable form, so to speak. That is, you start with x cubed, no x squared term occurs. After some changes of the, suppose you have an equation like ax squared plus bx plus c, x cubed plus bx squared plus cx plus d equals 0. You can make some linear change of variables and things like that and reduce it to the form x cubed. If you can solve x cubed, no x squared term, x cubed plus ax plus b equals 0, then you can solve the other equation, you can manipulate and get it. So the equation will reduce to this, and this can be, for this you can write down explicitly the equation. It will now, of course, actually involve cube roots. Write square root of b square minus 4ac, because it's a cubic equation, you can expect it to involve the cubic and so on. So this was done somewhere in the 11th century, 12th century, cubic equation solved, and soon after the biquadratic, the fourth degree equation, was also solved. The fifth degree equation remained unsolved for a very long time. Nobody knew how to handle the fifth degree equation. And with very good reason it turned out. Abel actually proved that you cannot solve the fifth degree equation like you can solve these other equations. It's called, that is, he wanted to say, take all the coefficients and manipulate with them, like add, subtract, do all kinds of things. Take square roots, cube roots, fifth roots, nth roots, any n. Allow all these processes. Using all these processes, you cannot write down the solution. In terms of the coefficients, it's not possible to do it for a fifth degree equation. This is what Abel proved. And as a matter of fact, Abel proved this and sent his manuscript to the greatest mathematician of his times. Gauss, Carl Friedrich Gauss is considered all-time great mathematician. He sent it to me. But unfortunately heard nothing from Gauss. Gauss was, cannot blame Gauss too much, because Gauss was probably used to getting lots of cranks writing to him saying that they solved this, solved that, and send their papers to them, and he was probably too tired to look at claims of this kind. Probably jumped into the waste basket without taking a second look. But it happened to be the odd man who had actually done something profound, actually shown it's not possible to do. That's happened. And then in those days, Norway was not a very advanced country. It was a really poor country in Europe, and he had difficulty in getting support for his pursuing mathematics. In fact, his father died when he was quite young, and he was something like 16 and had 7 siblings to take care of, all younger than him. So he managed to support the family by taking tuitions for school children. Anyway, at some point, his friends who always knew his worth managed to get him some money so that he could travel to important centers in Europe. He went to Göttingen in the hope of meeting Gauss. He did not meet Gauss. Then he went to Paris to meet, trying to meet some of the big shots in Paris. Didn't succeed. Came back a somewhat disappointed man. And here, tuberculosis. The day after he died, there was a telegram from Germany offering him a professorship at a place, forget, in Berlin. He had been offered. The telegram came one day too late. There's also a somewhat filmy story in this connection. Apparently on his deathbed, he called his best friend and he called his fiancée and made them promise that they would get married after he died. And they did. So was the story. Rather finished. Anyway, Well, that's a gossipy account about some mathematicians. Well, the thing is that, of course, India has a long tradition of achievements in mathematics. On the other hand, there's a strong tendency also for our people to claim all kinds of things which are false. The so-called Vedic mathematics is just rubbish. What they call Vedic mathematics is neither Vedic nor really serious mathematics. It's a bag of tricks for making calculations, actually invented by a certain Chakracharya who had a mathematics background, and he put it in somewhat cryptic Sanskrit verses, and they had to be interpreted, and he gave the interpretation as such and such. But I think he was a clever guy. He made some nice tricks, but that is not what mathematics is all about. You're finding tricks for calculations, especially with computers these days. You don't need such help to do that. But he passed it off as Vedic mathematics, trying to gain. It worked for him well in both ways. First of all, he claimed for the Vedas much more than what they had to offer, and claimed for himself a distinction as a great Vedic scholar. So, anyway, that's all rubbish. But on the other hand, ancient Indians did make considerable progress in different things in mathematics, and some of the achievements are, of course, wonderful. The discovery of the zero, everyone knows, is Indian discovery, and that is certainly one of the most profound things that has happened. And the place value system for writing numbers, which is arguably the most important discovery in applied mathematics. It's really applied mathematics. But you can see its use. On the other hand, it may not have been invented for the sake of applications, because in the days it was invented, it's supposed to have come into existence already by the 4th century AD or 5th century AD. At that time, they would never had to deal with big numbers. Only when you deal with big numbers, this representation becomes important. If you want to add, multiply, things of kind, the representation as usual representation of numbers in the decimal system becomes important. But in the 4th century, they never had to deal with numbers of that kind. Even now, the numbers, big numbers are limits, not really worried about that. So the chances are that they wanted some kind of order in the chaos. The numbers go on and on and on. How do you represent them? Somebody must have thought. It's more aesthetic drive than anything else that made them discover this theory. That is my personal theory. In general, I have a strong tendency to think of mathematics more as art than science. Because if you look at the development of mathematics, what has driven mathematicians? Not necessarily applications. Okay. Applications do matter. Physics has contributed a great deal towards development of mathematics. But if you look at number theory, you look at Euclid's geometry, there are some theorems about triangles which may be useful. But there are all kinds of peculiar properties of triangles which he discovers which can have no earthly use. The only reason he was doing it was he thought it was exciting, it was beautiful. That's the reason why Euclid wrote all those theorems. All the theorems that Euclid wrote down, those of practical use maybe half a dozen, but the rest of them are not of any great use. And even then, the way he wrote it down also. For applications you don't have to do it the way he did, developing the idea of what is given, what is to be used, what is proof and things like that. That's a completely, that is the characteristic of mathematics after all. And that has nothing to do with applications. It's an internal thing for the discipline. So it's really aesthetics that drives mathematics. Later, all questions in number theory, take Fermat's class theorem, which caused so much excitement among mathematicians. So what? The experiment was y bar equals z1, there's no integral solutions. So what? What does it make? What difference does it make? It has no earthly use. The fact that it doesn't have solutions. Maybe the quadratic, x squared plus y squared equals z squared may have some use because you can have triangles and you can determine what are the triangles with the integral sides and so on. Maybe it has some use, but otherwise, cubes, 4 powers, no earthly use whatever they have. Nevertheless, mathematics was obsessed with it for 300 years before someone solved it. And Fermat himself in his margin writes, I have a beautiful proof of this result. Beautiful is the word used. And you can also see, among scientists, the word beautiful is used more often by mathematicians than other scientists. And very often mathematics describes the proof as beautiful. Of course, your website has this quotation from Bertrand Russell about mathematics has an austere beauty and so on. I noticed that. It's a Bertrand Russell is a name which many of you would have come across. He's essentially a philosopher, but started out as a mathematician. And it's many people do talk of mathematical beauty, not only Bertrand Russell. In fact, there are many physicists who think mathematics is beautiful. And of course, I certainly think mathematics is beautiful. And it is search for beauty rather than anything else that drives the mathematician. Not so much to solve world's problems. But if the world's problems get solved with some mathematics, well and good, I'm happy, I'm not unhappy about it. But that is not my motivation. I pursue mathematics because mathematical structure in itself is beautiful, and I would like to understand it better and better and better. That is the motivation for most mathematicians. For instance, if you take this is the theorem of Euclid, which many of you would have come across, maybe know a proof, Euclid's proof. It says that there are infinitely many primes. You people know the proof that there are infinitely many primes. You know what a prime number is. Prime number is a number which has no divisors other than itself and 1. That's a prime number. And prime number is not, 1 is not a prime number. And Euclid stated that there are infinitely many primes. If there are infinitely many primes, it makes no difference to our world. But he was curious about it. He posed this question. He asked himself the question: are the number of primes finite? Does it stop, or does it go on and on and on? And he actually proved that there are infinitely many primes. And this proof is one of the most beautiful proofs in mathematics. It's very elegant and very quick. How can you do it? Suppose there are only finitely many primes. You will arrive at contradiction. You can list the primes. P1, P2, Pn. It stops there. Now look at this. What's a prime? A prime is a number which has no divisors other than itself and. Now look at this number. Take this product. Take the product P1 into P2, Pn. Add 1 to it. If this is a prime, it's a contradiction. I have said P1, P2 are all the primes. Suppose it's not a prime, then it is divisible by some number smaller than itself. And therefore it must be divisible by ultimately be a prime, because you can keep on, it's divisible by some number. If that number is not a prime, you can divide it again. And so it has to have a prime factor, so to speak. Any number has a prime factor. Take a number, if it doesn't have a prime factor, it has some factor. That factor is smaller. So by induction you can say, smaller numbers have prime factor. So it has a prime factor. What is that prime factor? So Q is a prime factor. But Q cannot be any of these, because if we divide this by any of these, the remainder is 1. That's the way I have arranged it. Take this number, divide it by any Pi, the remainder is 1. Whereas if Q divides it, the remainder is going to 0. So Q is distinct from P1, P2, Pn. So what is it? I've listed you entire set of primes P1, P2, Pn. Now I find a prime Q, which is different from all this, because this Q divides this, but none of these can divide it, because the remainder always is 1. So there must be a prime which is larger than any P1, P2, Pn. So it's a contradiction. Or you can say, anyway, you can also make it a proof without contradiction, directly saying, take the first 10 primes, add 1, take the product, add 1, it must have a prime factor which is different from all this. So I will produce a prime which is, so there are infinitely many primes is the conclusion. This was Euclid. And why was he interested? There is no earthly use for this. No, primes themselves have not been of any great use till recently. Nowadays in cryptography, primes have great importance. The large primes are used in the context of developing codes and things like that, in security, so to speak. Anyway, so as I said, my own feeling, and which is shared by many other mathematicians, is that the main drive for mathematics is the search for beauty, which certainly qualifies it as art rather than science. The natural sciences, of course. There's one more thing, see, when you look at natural sciences, you can build beautiful theories, but there's one factor which disciplines them. That is, you can build beautiful theories, but unless the theory agrees with actually what happens on the ground, in nature, the theory is useless, it will be rejected. Mathematicians don't have such constraint. You build a theory, it's beautiful, that's it, we're happy. We are not worried whether it is defies nature or something. There is no nature to interfere. It's our thought processes, it's our mental constructs that we are looking at, and their beauty is what drives us to everything. So disciplining factor is aesthetics in mathematics, which is also the case in art. What disciplines are is beauty. I mean, any old person can go and paint something or other, but people like it only if it's beautiful. And so aesthetics is what disciplines the artist. Similarly, aesthetics is what disciplines the mathematician. Of course, there's another discipline, namely rigorous proofs. Proofs have to be argued out thoroughly and so on. That is one aspect, which is more like science. But there's this other aspect, which is a disciplining factor, which is not usually recognized for what it is. It's a disciplining factor, and that is aesthetics. And in fact, generally, people are scared of mathematics because of this other disciplining factor, namely rigorous proof is what bothers many people. If you can convey the beauty of mathematics, you will get over that fear. So I think this society has been making efforts to get students to like mathematics. One of the important things is to be able to convey the beauty of mathematics. It's not so easy, but that would help much more than telling them this is useful, that is useful. I don't think that will motivate students as much as conveying them the beauty of mathematics. Well, I think I've spoken long enough. Thank you for your attention. I hope you didn't find it too boring. That's all I can say. I'll be happy to answer any questions if you want to ask me. Doesn't have to be related to what I talked. It can be random. Yes, please.
So you were saying that a lot of people, mathematicians from India and Tamil Nadu. Now I want to know or how we Indians are faring and who are doing the most number of research work in mathematics.
Which part of the country?
Which part of the world?
Which part of the world? Well, America is in the leadership place without question. And of course, but you know, when you say America, what is an American? And most of the Americans who are doing great mathematics, for instance, are imported from Europe and elsewhere. So it's not clear. Russia was in the forefront, but unfortunately, most Russians have now migrated to the West. All the good, great mathematicians of Russia, unfortunately, migrated. In the 60s, Moscow was one of the greatest centers for mathematics. It was a fantastic place for mathematics. The 60s, 50s and 60s. But unfortunately, after the breakup of the Soviet Union, most of the really outstanding Soviet mathematicians moved out, and most of them in America or in Europe. And historically, the country which has been in the lead in the last 500 years was France. Before the United States became that important, France closely followed by Germany. France and Germany were the real mathematical powers. Britain came a little after them. Britain was pretty good, but Britain comes a little after them. But France and Germany were the leaders in mathematics for the last many centuries. And in fact, the Tata Institute of Fundamental Research, which has been doing excellent work, I would say, was influenced greatly by French mathematicians. What happened was this man, K. Chandrasekharan, who was the first head of the mathematics group in the Tata Institute. He was an extraordinarily good organizer. He was a good mathematician, but his strength as an organizer was even superior. So, pretty good mathematician, but as an organizer, he was even better. And what he was able to do was to bring really outstanding French mathematicians to visit Tata Institute for periods of 3 months. At Tata Institute, all he had was students. I mean, they were faculty, but none of them of really big standing. He himself was one of the better people, and he had one other colleague who was good, but others were all ordinary people, and it was not as if the foreigner would want to come and spend time at Tata Institute to talk to these mathematicians. They came and taught the students, and it turned out he had selected the students very carefully, and the students took to mathematics like fish to water, and they did. The first successes were one of my teacher, M S Raghunathan, and C.S.H.R. who were two big names, internationally known big names in mathematics. And so many French visitors who came to Tata Institute at the time were really outstanding mathematicians. But when they came, they were probably not that well known. Chandrasekharan knew how to spot great people ahead of their greatness becoming apparent to everybody, and he managed to get some of them to come to Tata Institute, and they would visit for 3 months and give course of lectures, and the Tata Institute is essentially built on those courses. That is what gave exposure to students there to current mathematics, interesting mathematics at the cutting edge of research, and some of them are very talented, so they jumped into it. So that one great achievement of Chandrasekharan, the important quality he had was he did not force people to work in his own specialization. He himself did some classical numerical, in fact, probability, Cambridge kind of stuff, but he did not insist on any of his students pursuing those things. He let them have a free time and got them exposure to good mathematics, and if they picked up some good mathematics and wanted to pursue it, well and good. He let them alone. And turned out they were very talented, and some of them did very good. There were these two people, Narasimhan Seshaji, and there was a man named Raghunathan. But where they were, all these people came from Chennai. Most of them from Bala College. I myself went to Vivekananda College. But anyway, these people came from Bala College and were greatly influenced by Father Rassim, whose name I mentioned. Father Rassim was he was not a particularly good teacher, in the sense that he spoke English with a French accent and mumbled most of the time, so students would find it difficult to follow him. But when the student, the bright student, took a special interest in this person, and he could develop their talent. The very talented people benefited greatly from it. And there's another Narasimhan, Raghunathan, who did extraordinarily well. He eventually moved out of the country, went to Chicago. Then there was a man who died young, C.P. Ramanujan, who was also an outstanding mathematician. These are all the names which are known in the international community. If you are working in algebra geometry, you will know the name of Ramanujan. If you are working in complex analysis, you will know the name of Raghunathan. They have done work of such importance that the names are known. Their theorems are important theorems.
About the Bourbakians,
Okay, that's an interesting thing. After the First World War, the French lost many of their mathematicians because there was conscription. People were sent to fight at the battlefront, and even mathematicians were not spared, and academics were not spared. They were all taken to prison. Many mathematicians lost their lives in the First World War. So at the end of the First World War, the state of affairs in France was pretty bad. There were no good teachers, nothing around. And then it became more and more apparent as not immediately obvious, but some 10 years, 15 years later it became obvious. And then people like André Weil, who came to India, realized that this is happening and they should do something about improving mathematics in France. And for that they thought one of the things they should do is to write books which are meant for college students. And they embarked on this program of writing books on at the undergraduate level. And they found a group which called itself by the name Bourbakian, B-O-U-R-B-A-K-I. It's a name somewhat childish of that group, because it's the name of an obscure general in the French army. It's nothing to do with mathematics. It just took some fancy. In fact, the name was selected by André Weil. André Weil is one of the founders of this group. They wrote many textbooks, essential textbooks, which are very good. In fact, I was brought up on Bourbakian books at that time. Thanks to the French influence. Many of us at that time were English, but they were all in French, and so we were forced to learn some French. But it's not difficult to learn French for reading mathematics. I want to read the literature, that's a different matter, but reading mathematics in French is not so difficult. Some rudimentary grammar and a few words, and you can manage it. And the way we learn French, for instance, is to not to go to any classes. We had self-instructors, plus we would take some mathematics book in French. The mathematics was something which is known to us. So you read that and then you know what's going on, so you pick up. That's where we learned, some of us learned French at the time. We did that for German also, but German is a lot tougher. French is easy, relatively speaking. Anyway, the Bourbakian is such a group, and the group continues to do something, but they no longer write books. They hold 3 times a year they hold seminars in France where the leaders speak on topics which are recent and have had a big impact.
Do they still exist?
The group exists, but it's no longer as energetic
As
or
active as.
as it used to be, And those days the mathematicians who were members of the Dubaki group were really 20th century's great mathematicians. Now we can't say the same thing. There are somewhat more mediocre people who are running it. They're also doing a good job, but that's it.
So your finally your advice to the students for pursuing mathematics.
Well, this may be a little unorthodox.
Yes.
The only reason you pursue mathematics is that you enjoy it. If you don't enjoy mathematics, don't pursue mathematics. That's the first thing you should know. It's not pursue mathematics. But the fact that you are here indicates that you do enjoy mathematics.
See, not really. Do you still feel that youngsters today show this kind of enthusiasm for pure maths?
Who?
Today's youngsters.
Youngsters?
Yeah. Do they display that kind of enthusiasm for pure maths?
What today's youngsters? What exposure do they have to pure
Yeah,
mathematics?
that's what I'm asking.
They don't have the exposure.
Yeah. It's
And
not exposed.
the problem now is that not many students take to mathematics in the first place at the undergraduate level already. Mathematics is one of the subjects which is least popular with students, right? Am I right?
No, but people who come, at least you have 60 in a batch, right? 60 in a year.
Yeah, but what compared to other subjects, there is a demand for a degree in any case. So, but mathematics is one of the least
Yeah.
sought after. It's much more difficult to get into physics BSc or chemistry BSc than to get into mathematics BSc in our colleges, for instance. So the point is that I don't know, it's difficult to say. If you have
I think the innate love.
one can see already at the school level whether a student likes mathematics or not. Those who like mathematics should have the opportunity to pursue it further. And while the number of people who are scared of mathematics, there are also a good number who like mathematics. In fact, the reaction to mathematics is either extreme. Either somebody likes mathematics immensely or he dislikes it immensely. There's no in-between thing. So, and also people don't know what it means to pursue mathematics. People don't know either what it means to pursue physics, but there's a vague feeling that physicists can talk about things which people seem to understand, whereas mathematicians really cannot make it reasonably popular. The only kind of popular thing I can be done is the kind of thing I've done personally. So it's not, which is not taken as serious mathematics anyway. So it's if students are given proper exposure to mathematics, I think interest will pick up. And if interest picks up, then there's a future. And the distinction between pure and applied mathematics is really artificial in some sense. What is applied is essentially something which is useful, so to speak, and it goes in some other field. But the mathematics behind it was often not developed because of that. It was developed independently. For instance, there is relativity. An important role is played by what is known as Riemannian geometry. Relativity is based very much on Riemannian geometry. Riemannian geometry was developed by Bernard Riemann in the mid-19th century, for purely aesthetic reasons. He had no physics in mind, nothing in mind. Purely aesthetics. He wanted to take geometry further than what had been done before him. And it is in that context that he developed the Riemannian geometry. But it turned out, without that, there was no relativity. So the point is that even at a certain point of time, mathematics may look as if it has no use whatever. It can become very useful at a later point. Again, group theory. Group theory is now become very important in various branches of science, in crystallography, in quantum mechanics, everywhere group theory comes up. But the group theory was not developed for any of these reasons. People were really looking at permutation groups, and some of that excited people. And it came up in the Galois developed in the context of solving algebraic equations. It had nothing to do with any applications. Algebraic equations, 5th degree equations, higher equations, it's of no earthly use. Never come across an equation of beyond the cubic or biquadratic anywhere in physics or elsewhere. But still, the mathematicians were interested. developed because of aesthetics. As I said, aesthetics has very much been the reason for the mathematical development. Anyway,
Almost little thing.
yeah,
Cryptography.
fine.
Any other questions? See, the transition from school to college at the undergrad level, do you think it's a very wide gap? How do you handle this phase?
Actually, I'm not competent to comment on this because I don't know. I've not looked at the undergraduate syllabus since my son went to undergraduate classes. No, I don't think the difference is more like the student is left more to himself when it comes to college. Self-study becomes much more important. That transition is probably difficult for many people. And the other thing is that in our system, as I say, it seems to me that the most difficult exam is 10th standard, then +2, then BSc, then MSc. PhD is a walkover. That's the way it seems to work. It's easy, you can even see that it's easier to score high marks in BSc than it is in +2. And MSc is trivial. That's the way it works. So the effort needed seems to decline, which should not be the case. The way the whole thing should be organized is that the toughest period should be the undergraduate period. Because that's a time when you are young and full of energy, which has a strong tendency to get diverted to other things. So if you put pressure at that point of time, you probably learn properly. And no, the point is that the learning process, one must enjoy the learning process. Hard work is enjoyable. That's something which people have to know. And people talk of talent. There are characters who think they are very talented, but when they find that they don't do very well, they excuse themselves by saying, "I'm talented if only I work hard." This is rubbish. Part of talent is capacity for working hard. If you don't have capacity for working hard, you won't have talent. And it's important to work hard. And working hard at the time of the undergraduation is probably the most important thing, because that is when you have the maximum energy, which has to resist being diverted into other things. So the point is, any bright student finds when he gets a undergraduate class, what you learn in class is not all that difficult. It doesn't take all that much effort to understand. So it's probably more difficult to learn things in the 12th standard. That's my personal experience. In my school days, things were tougher than in my college days. I don't think things have changed very much since then.
I find it the other way.
You find it tough? Well, I'm happy that you find it tough too.
I find it the other way because something which was completely numerical and easily.
Sorry,
It's very cold.
Not for me, but for him.
Sir, though many mathematicians have done tremendous work, none of them has been awarded Nobel Prize. Is there any reason behind it?
There is no Nobel Prize available for mathematics.
Is there any politics over it, or is there any reason?
There is a very interesting story which is not true.
So let me talk this.
You have probably heard the story. So your question is loaded. You wanted me, what the story?
It is a PhD story.
That's not true. Because, the story is the model. It's an interesting story. It is totally false. But nonetheless, the thing is good to know. And it proves one thing, that mathematicians are quite capable of malice. That's what it's true. The story is this, that why is there no Nobel Prize in mathematics? Have you people heard the name Mittag Leffler? Mittag Leffler was a mathematician, Swedish mathematician. And he was also a kind of ladies' man. He was very popular with women. Now, the story is that Alfred Nobel's wife fell in love with Mittag Leffler, and they had an affair. And when Nobel wanted the prize instituted, he inquired if there's a chance of Mittag Leffler getting it. And he was told, yes, there is a chance. And so we decided against instituting the prize for Mittag. This is the story. This falls for several reasons. Number one, Alfred Nobel never married. But this is an easy thing to dispose of. No, it was not his wife, but his girlfriend. Okay. Well, but more seriously, Mittag Leffler was always lived in Stockholm, and Nobel always lived in Paris. So it's difficult for them to. So it's, and actually, this there is an article in a magazine called Mathematical Intelligence. I don't know if you have come across this. It's an interesting magazine which is full of interesting things about mathematics. It's not, there is some mathematics also, but about mathematics, stories and things like that. Where there is an article in which the story is first given, and then long whatever, not explanation, whatever. There's a long account after that showing that it's not true story. So Sweden was the first country in which women could be professors at university. Till then, women could not be professors at university, and Mittag Leffler was the man responsible for doing that. And the most famous, one of the most famous names in mathematics, women mathematician, there are not many. The famous name is Sonia Kovalevsky. She did some work in partial differential equations and something about the dynamics of motion of the top. She's one of the big names. She lived in the 19th century, and she was actually Polish in origin, Polish-Russian, and she made a manager of convenience. In Russia, she couldn't pursue mathematics, so she wanted to go away to Europe to pursue mathematics. And for that reason, she had a manager of convenience with this man named Kovalevsky, and they traveled to Europe, and they separated. They were never together after that. And she became a student of famous mathematician Weierstrass, a name which I expect you would have heard, and did some work.
தொடர்ந்து தரப்பட்ட சமோசா சுவையாக இருந்ததா, அல்லது தொடர்ந்து வந்த அந்த பிஸ்கெட் சுவையாக இருந்ததா, அல்லது காஃபி சுவையாக இருந்ததா என்று கேட்டால் எல்லாமே சுவைதான். இன்னும் ஏதாவது வரப்போகிறதா தெரியவில்லை. எல்லாமே சுவைதான் என்றாலும் எல்லாவற்றையும் விட சுவை இன்றைக்கு உண்மையிலே உணர்ந்து சொல்லுகிறேன். உரைதான். பொதுவாக நம்ம வழக்கத்தில் சொல்லுவோம், நேரம் போனதே தெரியல. உண்மையிலே இன்றைக்கு நேரம் போனதே தெரியவில்லை என்பதுதான் உண்மை. அந்த அளவிற்கு மிகச் சிறப்பான ஒரு உரையை வழங்கினார். ஆரம்பத்தில் ஐயா சொல்லும்போது நீங்கள் கவனித்தீர்கள் என்றால் ஒன்றை சொல்லியிருந்தார். சம்பந்தமே இல்லாமல் நான் பேசுவேன் அப்படின்னாரு. ஆனால் அது பொய். ஆரம்பத்தில் தொடங்கி இறுதி வரையில் தொடர்ந்து சம்பந்தத்தோடு தான் எல்லா விஷயங்களையும் ஆலோசினார், ஆராய்ந்தார். அதுதான் உண்மை. ஒரு இளைஞன்ட்ட கேட்டாங்க, வாட் இஸ் யுவர் டிஃப்ரெண்ட் பிட்வீன் யூ அண்ட் யுவர் ஃபாதர் அப்படின்னு. உனக்கும் உன்னுடைய தந்தையாருக்கும் என்ன வித்தியாசம்? இந்த இளைஞன் சொன்னான், ஒன்றே ஒன்று தான். என்ன? என்னுடைய தந்தையாருக்கு ஸ்டார்டிங் ட்ரபிள், எனக்கு ஸ்டாப்பிங் ட்ரபிள். என்னுடைய தந்தையார் ஆரம்பிச்சிடுவார், ஆரம்பிக்கிறது கஷ்டம். ஆனால் எனக்கு ஆரம்பிச்சிடுவார், ஆனால் முடிக்கிறது கஷ்டம். ஆனால் அழகாக ஆரம்பித்து அழகாக நிறைவு செய்திருக்கிறார். அன்புக்குரிய நண்பர்களே, எது சிறப்பான உரை? மேடை மீது ஏறி எதுகை மோனையோடு அழகாக கருத்துக்களை சொல்லுவது சிறப்பான உரை என்று நீங்கள் கருதினால் அது 25% தான் சரி. எது சரியான உரை என்று சொன்னால், ஒரு உரை முடிந்த பிறகு அந்த உரையிலே பல புதிய செய்திகள் இருக்குமானால் அதுதான் மிகச்சிறந்த உரை. ஐயாவோட உரையில கருத்துக்கள்ல ஏராளமான புதிய செய்திகள். ராமானுஜன் அவர்களுக்கு பிறகு நம்முடைய இந்தியாவை சேர்ந்த கணிதவியலாளர்கள் எத்தனை பேர் தெரியாத செய்திகள் பலவற்றை பகிர்ந்து கொண்டார். எத்தனை பேர் இருக்கிறார்கள், எத்தனை பேர் இறந்தார்கள், எத்தனை பேர் சாதித்தார்கள். எல்லா விஷயங்களையும் மிக குறுகிய நேரத்தில் நிறைய விஷயங்கள் இன்னும் சொல்ல வேண்டிய செய்திகள் மிச்சம் இருக்கின்றன என்றாலும் கூட எல்லாவற்றையும் அழகாக ஒரு மணி நேரத்தில் சொன்னார். அதுதான் சிறப்பு. செல்லுகிற பொழுது மனதுக்குள்ள பல புதிய விஷயங்களை அறிந்து கொண்டு சென்றால் அதுதான் மிகச்சிறப்பான ஒரு மணி நேரம் பேசினாருங்க அவரு. அப்படியா? ஆமா, ரொம்ப நல்லா இருக்கு. என்ன பேசினாரு? அதான் தெரியல என்று சொல்லுவது அல்ல சிறப்பான உரை. சிறப்பான உரை என்பது நம்முடைய சிந்தனையை கிளறி கொண்டே இருக்க வேண்டும். புதிய செய்திகள் பலவற்றையும் அது அலச வேண்டும். பொதுவா ஒன்றை மட்டும் இங்கே சொல்ல விரும்புகிறேன். மத்தியான நேரத்தில் எதை படித்தாலுமே அல்லது எதை செய்தாலுமே தூக்கம் வருமாங்க. அதுலேயும் கணக்கு படிக்க ஆரம்பிச்சோம்னா கண்டிப்பாக குரட்டையே வரும். ஆனால் இன்றைக்கு தூக்கமும் வராமல் குரட்டையும் வராமல் மிகச்சிறந்த சிரத்தையோடு அந்த உரையை வழங்கியதால் தான் பல பேருக்கும் ஆர்வத்தோடு அதை கேட்க முடிந்தது என்பது 100% அக்மார் கலப்பில்லாத உண்மை. இன்னொன்று, பொதுவாக ஒரு கருத்தரங்கம் என்று சொன்னால், சிறப்புரை என்று சொன்னால் உரை ஆரம்பித்து உரை முடிந்து விடும். ஆனால் இந்த சிறப்புரை 8வது ஆண்டிலே பை கணித மன்றம் ஏற்பாடு செய்திருக்கிற இந்த சிறப்புக்குரிய அந்த நிகழ்ச்சியிலே இடம்பெற்ற ஐயாவுடைய உரை ஒரு கலந்துரையாடலோடு, டிஸ்கஷன். எத்தனை கேள்விகள் வந்தன, எத்தனை தெரிந்து கொள்ள வேண்டும் என்கிற கேள்விகளோடு வந்தன. வகுப்பறையில் எத்தனை பேர் கேட்கணும். கணித ஆசிரியர் நடத்திட்டு அருமையாக நடத்திட்டு மாணவர்கள் ஏதாவது கேள்வி இருந்தால் கேளுங்க. உடனே ஒரு பையன் வந்து கேட்டான், ரொம்ப மகிழ்ச்சி. முடிச்ச உடனே கேட்குறாங்க அப்படின்னு. என்ன இந்த இப்போ நடத்தினீங்களே இந்த கணித பாடத்தினுடைய கேள்விகள்லாம் எந்த ப்ரெஸ்ஸில் பிரிண்ட் ஆகுது சொல்லுங்க. அந்த மாதிரி கேள்விகள்லாம் கேட்கக்கூடிய மாணவர்கள் இருக்கக்கூடிய நிலையிலே அற்புதமான கேள்விகளை எல்லாம் தெரிந்து கொள்ள வேண்டும் என்ற ஆர்வத்தோடு உண்மையிலே மிகச் சிறப்பான உரை என்றுதான் சொல்ல வேண்டும். அது மட்டுமல்ல, பை கணித மன்றம் ஏற்பாடு செய்திருக்கிற அந்த நிகழ்ச்சியில் நீங்கள் கவனித்தீர்கள் என்றால் நான் கவனித்தது ஒன்று. இதுவரைக்கும் பல கூட்டங்கள் சென்னை நகரத்தில் பல இடங்களில் நடந்து கொண்டிருக்கின்றன. உங்களுக்குலாம் தெரியும். அந்த கூட்டங்களிலே எல்லாம் கவனிங்க, அந்த கூட்டங்களிலே எல்லாம் வயது போனவர்களுடைய எண்ணிக்கை தான் அதிகமாக. ஆனால் பை கணித மன்றத்தில் மட்டும்தான் வயது ஆனவர்களுடைய எண்ணிக்கை அதிகமாக இருக்கிறது. அதாவது இளைஞர்களுடைய எண்ணிக்கை அதிகமாக இருக்கிறது. இது வேற எந்த கூட்டத்திலையும் காணாத ஒன்று. உங்களை பற்றியே நான் சொல்வதால் நீங்கள் கைதட்டாமல் இருக்கிறீர்கள். எனவே மிகச்சிறப்பான ஒரு நிகழ்ச்சியை ஏற்பாடு செய்த பை கணித மன்றத்திற்கும் அதனுடைய நிறுவன சிவராமன் அவர்களுக்கும், ஐயா அவர்களை அறிமுகப்படுத்தி பேசிய ஐயா பேராசிரியர் திரு சீனிவாசன் அவர்களுக்கும் மிகச்சிறப்பான ஒரு உரையை, இன்னும் தெரிந்து கொள்ள வேண்டும் என்கிற ஆர்வத்தோடு கூடிய உரையை வழங்கிய ஐயா அவர்களுக்கும். அதில் இன்னொன்றை கூட கவனித்தேன். ஐயா சொல்ல சொல்ல ஒரு சில பேர் குறிப்பெடுத்துக் கொண்டிருந்தார். ரொம்ப முக்கியமான ஒன்று. எங்குமே சொல்லுவது, எந்த கூட்டத்திற்கு நீங்கள் கலந்து கொண்டாலும், எந்த கருத்தரங்கத்தில் கலந்து கொண்டாலும், எந்த சிறப்புரையை கேட்டாலும், தொலைக்காட்சி பார்த்தாலும் கூட கையிலே ஒரு சின்ன ஒரு ஏடு, ஒரு டைரி, அதில் முக்கியமான கருத்துக்களை குறிப்பெடுத்துக் கொண்டே வருவது ஒரு நல்ல பழக்கம். ஏனென்றால் பிறகு அது மறந்து போயிடும். சில வேலை மறதி என்பது ரொம்ப இயல்பானது, மறந்து போயிடும். ஆனால் மறக்காமல் இருப்பதற்காக ஒரு சின்ன குறிப்பேட்டை நீங்கள் குறித்து கொண்டே வந்தீர்கள் என்றால் அது பிற்காலத்திலே இன் ஃபியூச்சர் உங்களுக்கு மிகப்பெரிய ஒரு உதவியை செய்யும் என்று சொல்லி, இப்படி பல நல்ல கருத்துக்களுக்கு களமாக இருந்த பை கணித மன்றத்தாரையும், களம் அமைத்து கொடுத்த பை கணித மன்றத்தாரையும், அந்த களத்திலே நின்று சதம் அடித்த, சிக்ஸர் அடித்த ஐயா அவர்களுக்கும் நம்முடைய மனமார்ந்த நன்றியை தெரிவித்துக் கொள்கிறோம். இந்த இனிய நேரத்திலே முறையாக நன்றி சொல்வதற்காக பை கணித மன்றத்தினுடைய நிறுவனர், அருமை நண்பர், பேராசிரியர் திரு சிவராமன் அவர்களை அன்போடு அழைக்கிறேன்.
Good evening to all. It has been a very grand occasion and a very special feeling for all of us because we had Professor M S Raghunathan with us today. In fact, sincerely, I had been trying to call him and ask him to provide this lecture for many years, as of I remember. But in most of the cases when I meet him, I could not even talk to him on many occasions. And actual thanks are due to our brother Professor Srinivas, who take immense care in the development of our association. So we should appreciate his interest in bringing, because this event could not have been possible because of his efforts. He was constantly striving me, and each time whenever a great personality like Professor come visit Chennai, he was the one who called me up and informed that, well, so and so has been visiting here, please come and meet him, and if possible we'll arrange for a meeting. And as our good friend Pandrangan told, we always insist upon not just counting how many functions we did per year, but how useful it could be. That is the most important thing that we take care. It is not done for records, like saying we conducted this many events annually, we conducted this many things this month and next month. There is no such record for us. But by God's grace and Ramanujan's blessings, we were doing considerable work, and I will tell you, sir, this association has grown many-fold since its inception 7 years ago, and we had been quite successful in spreading to a certain extent, if not to a very great extent, but our demonstrations, expos and other things were very well received by many young children, and I know many of them got much inspired and they took up the teaching positions now because of our efforts. That's one of the big things, and most of the people who help me even today were teachers now. So because of them this event was possible. We should all thank and feel very privileged for hearing Professor, because he was a very great personality, and you could speak about him for many times and many days together, as Professor Srinivas mentioned. But it is a special feeling for all of us, as rightly pointed out by him, that his mere presence itself is a blessing for all of us, and we are very much thankful, and we pay our respects to you, sir. There are certain things which cannot be described by mere words. This is one such occasion where I don't have words to describe the lecture that he had provided. How much you could expect in this limited time. So it's very difficult to speak on many things. It's very easy to concentrate on one particular topic and speak for 2 hours or 3 hours together, because you have points to discuss, you have so many results to derive. But it is generally not possible, because I myself being lecturing over many places, I found that lecturing for 1 hour, if you want to lecture for 1 hour very effectively, you have to prepare or read at least 10 books. It is not as easy as you think. Taking class is something different, because we know that this is what we have to do. We have prescribed syllabi. We know what book we need to follow. And before coming to the class, we thoroughly know in our mind what we should do. We have that things that coming around in our mind, and therefore we just project it in the class. So that would come naturally. It is not unnatural. But speaking before common audience and making them follow and enjoy the subject, as he said, exploring the beauty of the subject is something very difficult. And it cannot be done by many. As you see, I had been listening to several people's lectures over the years, but not many things would be as fruitful and useful like this. I always weigh things. I just cannot say something like it is useful or the common things, but you are very blessed today to hear so many things from just one particular lecture. He has spoken about Lie algebra, number theory, geometry, about exploring prime numbers. What many things you can expect from a single lecture. But that's a key thing that we have been blessed today, and we all were very fortunate to have hearing his lecture today. And in spite of short notice, people had come today. That is one of the most important things, because we came to know this only yesterday night. And I all thank you for having accepted our notice and coming here and attending this in spite of very short notice. And I would request you, sir, to come for a very big occasion another time, so that we can address more people in well advance, intimating well advance, because you need to address more people. Because of lack of time and being a working day today, we could not gather more people now. But there are many more who are very much interested. So I would request you on behalf of the association to come once. Thank you. With these words, I profusely thank all for making this function very successful, and Professor special thanks.
இந்த சிறப்பான உரையை வழங்கி நிகழ்ச்சியை பெருமைப்படுத்திய ஐயா அவர்களுக்கு பை கணித மன்றத்தினுடைய சார்பாக இப்பொழுது நினைவு பரிசு வழங்கி சிறப்பிக்கப்படுகிறது. அதோடு மட்டுமல்லாமல் பை கணித மன்றம் இதுவரை வெளியிட்டிருக்கிற நூல்களினுடைய தொகுப்பை ஐயா அவர்களுக்கு வழங்கி சிறப்பிக்கிறது. பை கணித மன்றத்தினுடைய நூல்களின் தொகுதி அனைத்தும் ஐயா அவர்களுக்கு வழங்கப்படுகிறது. அதோடு சிறப்புக்குரிய நினைவு பரிசு ஒன்று வழங்கப்படுகிறது. நிகழ்ச்சியினுடைய நிறைவிலே இருக்கிறோம். கிட்டத்தட்ட 1 மணி நேரத்துக்கு மேலாக ஐயா அவர்களுடைய உரையின் மூலமாக 2 செய்திகள் வலியுறுத்தப்பட்டிருப்பதாக நான் கருதுகிறேன். ஒன்று, மிக குறைந்த வயதிலேயே பல கணித மேதைகள் இறந்து விட்டார்கள் என்கிற ஒரு தகவலை பதிவு செய்தார். ஆனால் அவர்கள் செய்த சாதனைகளையும் பதிவு செய்தார். அதனால் நாம் தெரிந்து கொள்ள வேண்டிய செய்தி என்ன என்று சொன்னால், கவிஞர் வாலி அவர்கள் அழகாக ஒரு திரைப்பட பாடல்களை குறிப்பிட்டிருக்கிறார். எத்தனை ஆண்டுகள் ஒரு மனிதன் வாழ்ந்தான் என்பது கேள்வி இல்லை, எப்படி வாழ்ந்தான் என்று அறிந்தால் வாழ்க்கையில் தோல்வி இல்லை என்று எழுதியிருக்கிறார். அதுபோல எப்படி வாழ வேண்டும் என்பதை இந்த கணிதவியலாளர்கள் மிக அற்புதமாக நமக்கு சொல்லியிருக்கிறார்கள் என்கிற ஒன்றை மிக அழகாக பதிய வைத்திருக்கிறார். என்கிற இந்த சிந்தனையோடு நாம் அனைவரும் தற்காலிகமாக பிரிவோம். மீண்டும் ஒரு நல்ல நிகழ்ச்சிகளை சந்திப்போம் என்று சொல்லி அனைவருக்கும் முறையான நன்றியை சொல்லி விடைபெறுகிறோம். மீண்டும் சந்திப்போம். நன்றி, வணக்கம்.